Hello and welcome back. In this video, we will be discussing predictions and extrapolation. This is a nice, easy one. All right, some vocab to consider. Prediction, using a regression equation to estimate an unknown value. Interpolation, prediction within the observed x values. Extrapolation, predictions outside the observed x values. And observed range, the smallest and largest x values in the data set. Okay. All right, so let's take a look at an example. So here in this table here, we have our X values for our studied and our Y values for corresponding quiz scores. And again, I have a video already covering least squares regression line. If you're not familiar with that, please check out that video. But based on the data, we have a least squares regression line of y hat equals 5.65x plus 44.93, which is, you could say, our prediction line based on the data, okay? So before I even read it, this graph here shows our plotted data, and the line here is our y hat line. Okay, this is our prediction line based on the data. So interpolation, use the regression equation to predict the quiz score for a student who studies 5 hours. The prediction is inside the observed range 1 to 8 hours, so is an interpolation and is generally considered reliable. Okay, so interpolation is when our prediction is based within the observed range of given values, and we look at where the least squares regression line is for the inside range. So the inside range is 1 to 8. We're predicting 5 hours. So 5 hours, we would plug 5 into the equation. I don't know exactly what that is from looking at it. It looks like it's like 72-ish. And at 5, okay, cool, 73, you know. The highlighted prediction lies within the observed data, so nearby observations support the estimate, okay? So more importantly is extrapolation. I'm sure you've heard in some sci-fi movie, oh, extrapolate the data. And that means make a prediction outside the variables based on the given data. So like, what does that look like? So here's the same data from that we were given before with the test scores. And you notice here 12 is outside. Okay, so let's read this first. Predict the quiz score for a student who studies 12 hours. Okay, because 12 hours is outside the observed range, this is extrapolation. The calculation is valid, but the prediction may not be. So this is a prediction based on the regression line that we're given. So we would plug 12 into the regression equation, and it should be a little bit above 110. Let's do that really quick. 5.65 times 12 plus 44.93. Yep, 112 point. So I'm going to say, let's go here. Let's make a note. When x equals 12, our y hat equals 5.65 times 12 plus 44.93. And we could say y hat equals 112.73. Okay, so this is saying based on the data given, we can estimate that if a student studies 12 hours, this is the score they're going to receive. Okay. I'm sure it's covered with the common mistakes, but let's just talk about this a little bit. With extrapolation, now you kind of have to use some common sense here. Like, yeah, sure, based on the trend, this would be the score, but tests are typically out of 100. So would a student score 112? No, they'd probably just get the 100, and the student test scores line would look more like this, 222, and then at 100, just kind of block off. The more you study, you can't get better than that 100 grade. Okay, so while extrapolation is not always going to be accurate, depending on the given data, it could give us some very useful predictions, okay? All right, some common mistakes, confusing interpolation with extrapolation. I think it's easy, inter in, extra, literally extra out. 2, believing every calculator prediction is equally reliable. They should all be close enough to each other, but they will vary. And 3, forgetting to check the observed X range before interpreting a prediction. All right. And here we have some practice problems. Number one, use y hat equals 5x plus 18 to predict y when x is 6. 2, observed x values are 2 to 10. Is x interpolation or extrapolation? 3, observed x values are 2 to 10. Is x equals 15 interpolation or extrapolation? And 4, explain why extrapolation can be misleading. Feel free to pause here and take a stab at these. Cool. Hopefully we did that. Let's take a look at the solutions. So number one, when y hat equals 5x plus 18, what is y hat when x equals 6? Just plug 6 into the equation. Easy peasy. 5 times 6 plus 18 equals 30 plus 18 equals 48. Predicted y equals 48. Predicted y or y hat, they mean the same thing. 2, if the observed x values are 2 to 10, x is within that range. 8 is within that range. That's interpolation. 3, again, x values are 2 to 10. X is 15. That's outside the range. That's extrapolation. And 4, y extrapolation can be misleading. The trend may not continue outside the observed data. Like the example I gave before, you can't have more than 100 on a test score. Cool. All right. Easy peasy. That's all I have for you on this topic. What did I title it? I always forget the title. Prediction and extrapolation. There we go. Thank you for tuning in. As always, a link to the notes will be in the video description, and I will see y'all next time. Take care.